Hello everyone, welcome back. I'm MathBoy, and today we're going to be starting our chapter, I don't know if I'll finish it, hopefully I will, on logarithms and exponential functions. And so we're going to start this off with, we're just going to talk about an exponential function. So this is our basic exponential function, f of x equals a to the x, where a is greater than 0 and a does not equal 1. And a doesn't equal 1 because if I had f of x equals 1 to the x, for every number x, f of x is that same thing. So it's pretty much just the same thing as saying f of x equals x, which is just a linear function. That's not an exponential function. And I'll just show you that if I plug in 2 for x, 1 squared. Oh wait, no, sorry. I'm sorry. F of x won't equal x. X will always equal 1. So this function will just give us a graph that looks like, what is it? This. Because 1 to the 0 equals, to the 0 power equals 1, 1 to the first power equals 1, 1 squared is 1, 1 to the third is 1, and we'll just get 1 for every value. So this, a cannot equal 1 because it's just a constant function, it's not an exponential function. That's really it. This first part of this chapter, this lesson, is just what's an exponential function, what are its restrictions. So let's jump into graphing them. Okay, so now it's time to talk about actually graphing these things, a few patterns we're going to go over, and then we're going to practice a little bit. So f of x equals a to the x. If I plug in any number for a, let's just say f of x equals 2 to the x. We're going to do that graph real quick. And just saying, I found that the easiest way to do these graphs is just to make a table of values. Not like memorize points, because in parabolas you can memorize points and apply transformations. It's just easier for these to make a table of values. So x and y, because f of x is pretty much just y. When x is 0, y is 1, because 2 to the 0 is 1, so 0, 1. When x is 1, y is 2, because 2 to the 1 is 2, so that's 1, 2. X is 2, y is 4, so it's going to be 1, 2, 2, 3, 4. And then x is negative 1, I don't have room. Negative 1, y is 1/2, and just so on. So an exponential graph is going to look something like this when x is positive. And I'm going to talk about 2 points right here, 0, 1, and 1, 2. If I did f of x equals 3 to the x, plug in 0 for x, it's 1, just like here. So, because anything to the power of 0 is 1, a point on any exponential graph, unless it has a transformation, is going to be 0, 1. And then the other point, 1, 2, if we did 3 to the x, 3 to the 1 is 3. If you notice, the 3's are the same, and right here the 2's are the same. And so that'll always be 1, a, because a is our base. Unless there's any transformations, because that'll always mess everything up. Actually, it's only translations, because a reflection won't mess that up. So only if the graph moves, that'll be messed up. So that's pretty much it right here. Now we're going to go on to talk about other stuff about these. Okay, so now I'm going to do a quick review of transformations. Basically, I have our function f of x equals a to the x. So first we're going to talk about translations. The translations can be in two spots. Outside of the exponent or inside the exponent. If it's outside of the exponent, it'll go up or down that number. So if it's a positive number, it'll go up. If it's a negative number, it'll go down because up is positive and down is negative. And then in the exponent, x plus 3, it'll always go left or right because it's applying to the x values. Because we have to change the x values to accommodate for that plus 3. And because we actually have to change the x values to accommodate it, it's going to be opposite of what you think. So plus 3 will go to the left, which is the negative side, because we have to, for this value up here, x plus 3 to be 0, we have to make x negative 3 instead of 0, which is what it would normally be. And so basically we're just seeing what we'd have to do if x plus 3 was on its own. We're seeing what we'd have to do to get it all on one side of the equation where x equals that, and we would have to subtract 3. So it's really minus 3 instead of positive 3. And so those are the translations. And so now the reflections. I'm not going to talk about rotations because that's a bunch of geometry stuff. And this is not geometry, this is algebra 2. So there's two reflections that can happen. It can be outside, in front of the base, or it can be inside of the exponent, which should be like negative x minus 2. And if it's outside, it applies to the final, or like the y values. It'll make all the y values negative. So if our graph looked something like this, which it normally does, it would reflect across all the y's would be multiplied by negative 1, because the negative's applying to the final y value, and it would look more like this. And then if it reflects with the negative up here, it applies also to the negative 2, because like I said, it's like we're pulling out a negative, and we have to make that, and then it applies to the translation also, because we have to accommodate for the negative in front of both of them. So this is really negative x plus 2, which means a reflection over the x-axis, which will look like this. But then also it'll move to the negative side too, because remember in the parentheses it's always opposite of what you think. So it really looks something like this. And this is all just transformations. This is an earlier lesson. I'm just reviewing them right now. And there's one more thing. If we have f of x, it'll be a scale factor. 3a to the 1/3, 1/2, I guess, x plus 2. And then, once again, if the scale factor is on the outside of the exponent, like this, in front of the base, it'll go from this. All the y values will be multiplied by 3, which means it'll stretch upwards. If it's a whole number, if it's a fraction, it'll like compress and stretch sort of closer together with the y values. So this will look more like this. If it was a 1/3, it would look more like this. No, more. I don't know. It's sort of hard to draw accurately, but it would get below the line like that. And then if it's in the exponent like that, it's we have to accommodate for the x, for the scale factor being in front of the x, and so it's left and right, because that's like the x values. So 1/2 x would go from something like this to something like this. And then if it was 2x, it would go to something like this. And then that's just all transformation stuff that we did earlier, and you have to remember that this 1/2 will apply to the 2, so it'll actually turn to plus 1. And then when you move it 1 to the left, because even though it's plus, you move it towards the negative side because it's in the exponent. That's just a review of transformations. You should already know that. If you don't, then I reviewed it for you. So now we're gonna move on to other. Okay, so now we're gonna talk about something that's related to some application problems, or word problems that we'll talk about later with logarithms and exponential functions. Mostly when we talk about logarithms, this will be a very important number. And it's the mathematical constant e. It's sort of like pi, where, if I said pi, you're like, oh, 3.1415, blah, 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 blah. Basically, it goes on forever. It's a constant that you use, to determine, like, in an equation, like an important equation, like for the pi, it has to do with spheres and circles and stuff like that. Well, e is used in interest, and we'll talk about that later. Basically, all you need to know right now is what e is, and you don't really even have to know the value. Like, you might have to, but whenever I've had to know e, it was on a calculator portion of a test. And whenever it wasn't a calculator portion, it was okay to leave my answer in terms of e. Like, you can have 4 pi as your radius of your circle. So basically, just e is a less cool version of pi. And that's like all there really is to it. Okay, so we're going to talk about one more thing before we finish with this video, and it's interest. So this is basically the most common use of exponential growth, or e, like I said earlier. And basically, there's two formulas we can use for interest. If it's continuous, the equation will be p times the value of e to the rt. And then e was the constant we said earlier. P is the initial amount invested. R is the rate that it's invested at. And t is the amount of time. And that'll equal the amount of money you'll have after that amount of time. And so that's just written as p e to the rt. I just wrote the parentheses there so you know that the rt only applies to the e. And then if it's compound interest, it's a little bit more complicated. Compound. It'll still be p, which is the principal amount invested, times 1 plus r over n to the nt. And basically where that just comes from is you have the 1 here because the p will apply to that 1, and it's just p times 1 is the p plus p times the rate over amount of times invested per year to the nt. And n is amount of times invested per year. I don't think I have to write this. T is the time, and then R is the rate invested. And those are just the compound and continuous interest formulas. You just have to memorize those. They are very common word problems, very common application problems. There's a few other uses of this, but this is the most common one. And that'll about do it for this video. So I hope you enjoyed. If you did, please leave a like. Please subscribe. If you watched it this far, you probably like it. Don't forget to turn on notifications to be notified when I upload a new video. That'll probably be tomorrow, because I'm really trying to get a bunch of videos uploaded right now. Because, like I said in another video, this is a 20-time project and it's gonna end soon. If I don't get support, I won't do this anymore. So, support the channel, give this video a like at least. Subscribe if you really want to support it. And, yeah, just have a nice day. Turn on notifications so you get notified of every video I make. And that's about all. So, hope to see you next time, and have a nice day. Bye.